Hello everybody and welcome to the latest of our CODA decommissioning webinars. My name is Francis Norman. I'm CEO Managing Director with CODA. I am absolutely delighted today to welcome Darren O'Leary, who is with Restore Subsea, the brains behind the organisation of Restore Subsea, and he's going to talk to us about his alternate approaches to subsea pipeline removal, the technology and the thoughts that they've got going behind all of that. So with no further ado, I would like to hand over to you, please, Darren, to take it from here, please.
Well, yeah, hi everyone, and thanks to Francis and the team at CODA for making this possible. Restore Subsea is a R&D engineering firm with a clear focus on developing and commercialising lower cost and more environmentally robust subsea decommissioning solutions. XLA is our first patented subsea pipeline removal method. It's CapEx light and it's scalable and licensable, and reduces pipeline removal costs by 50%. So that's essentially the theme of my presentation here. So please observe the usual confidentiality protocols. So over the next 20 minutes or so, I'll take you through the following, and appreciate if anyone can flag any Q&A at the end. So framing up the problem, big global problem is, so we have a 6-minute video on our webpage. So not to bore everybody, I'm not going to take you through the video. If you haven't seen it, then please check it out after the webinar, while this is fresh in your mind. But in summary, we see a very big global problem with an opportunity to do things much better. And without reading through the size of the market and all the rest of it here, in summary, these 3 key points here, I think, is that on the left-hand side, Thailand's been removing greater than 300 kilometres of pipelines up to 2023 using DPS lay vessels. They've been cutting joints on board at circa 1.2 kilometres a day while capturing internal fluids. Their environmental risks are at ALARP levels. Australia, on the other hand, has removed only a small number to date to 2024. They've been using a DPCSV via subsea cut and lift. And this is at lower rates, that remove rates in Thailand, without the ability to catch internal fluids. And we see this as environmental risks and not necessarily at ALARP currently. And then just as a recent context, at the Energy Club, if anybody was there just a couple of months ago, Francis was hosting in the session, I picked up on a couple of notes there, and one of the notes there was Santos GM Decom had a note: I'm interested in spending $1 million to $2 million to save $5 million. Looking for better ways and better opportunities. Woodside's GM Decom was asked about new technologies, and he said reverse S-lay could be something promising on the radar in terms of interesting things that they see. And then it was good to hear also from the Schlumberger account manager, and he was talking about the common theme with new tech is there's good proof, but give me a first well to test. So that sort of just sets the tone, I think, of the problem. So in Australia, in 2025, DISA produced a liability that's estimated as noted here, with complete removal of rigid subsea pipelines as the base case. Shareholders have got limited insights to this, and Australian taxpayers could be on the hook for a majority of these removal costs. So DISA's report considered subsea cut and lift as the prepared pipeline removal solution, and because the quote is that it's more comprehensively understood from a technical and commercial perspective. Shown here are the traditional closed system methods, and for all of these traditional methods and cut and lift, the pipeline removal costs, as best as we understand it, are still in the range of $2.6 million a kilometre. I've got Singapore dollars here because our investors are in Singapore. So that's framing up the problem. Now, from a solution perspective, I'm not going to get into the technical on this slide, but I'll just say that when you look at the size of the market, we can reduce costs by greater than 50%. By 2040, this looks like something like a $17 billion removal market. And the question is, why does XLA trump other solutions? First point is because it reduces costs so much. Second point is the environmental risks are at ALARP. Third is it's patented technology with proprietary know-how, and it's doing something that most incumbents can't or won't do, which is a classic business trump. There's a capital licensing model. We're on a DMV pathway right now to qualify it, and there's growing regulatory driven marketplace. So into the technical. So, and as I say, there's a 6-minute video that explains this in further detail. But in summary, XLA is all about plastically deforming the pipe on retrieval, which will require much lower tension relative to traditional reverse S-lay, lower tension and shorter stingers. The equipment can be deployed on lower cost non-specific pipe lay vessels, such as hookup barges and DP vessels. It can then it can cut pipes into 160 to 400 foot joints if you watch our video, versus the customary 40 to 80 foot joints of a pipe lay vessel. These vessels have got lower day rates than pipe lay vessels, so you can read between the lines as to what generates the greater than 50% cost savings. And there's also reduced ESG impacts. It's patented, there's proprietary IP. This is this counter-positioning thing again. Incumbents generally can't do what we're doing. We're progressing the DNV qualification process in 2 phases, which is involving engagement with operators, contractors, and government. We've been on this journey for quite a while right now. In summary, on the slide deck, you'll see we've got a patent granted in the UK, pending in the US and Australia, and the DNV work that we're doing is essentially the work on the DNV work on the vessel. All of our technology is essentially standard industry proven technology. Most of the work we're doing to prove this up is around how far can you plastically bend pipe. That's the step that's there. So this slide here, traction and roadmap on a journey like this. So we've been at our commercialization stage now. We started just about a year ago. There's a long list of things that we've been achieving and ticking off as we're going along. And our focus now is on completing these steps that you see here. I won't go through them in detail, but key bits is essentially DNV technology qualification, a little bit of stuff about, doing some feed studies and getting a patent granted in Australia and a few other things. And then once we've completed that, we're looking at by the end of this year, we'll be at a point then where we've achieved product market fit, which is saying that the solution can be used, and then we're focusing on the next stage of growth. We've been building a great team to support the business. This team has got complementary capabilities and experience, which is what's required for the journey that we're on right now. I'm trying to communicate that in a Venn diagram, but so the way I see things with the problem we're trying to solve, you need operator experience, you need subsea engineering contractor experience, you need commercialization understanding, and then you need people coming together in the right crazy way that you can complement that. And so between myself, I've got like over 30 years of experience, started as a field engineer for McDermott in 91. Most of my background is all subsea construction and installation. Joining me is Adrian. Adrian Lim is our engineering director. He's got deep industry experience as a subject matter expert in Woodside with pipelines, Worley Parsons, engineering consultant, Rosen. So essentially all of the key pieces around engineering. Rob Creswell has joined us as a commercial advisor. He's got subsea installation and construction, as well as back in the days of Clough when we worked together, as well as now 20 years of Chevron, understanding of commercial and corporate strategy. Rosny has joined us as our executive assistant to try and get a little bit of craziness organized a bit better. Jinky Sankova is in the Philippines. She handles all our marketing, emails, all of our marketing, webpage, LinkedIn, et cetera. And then on the right-hand side, we've got a advisory board. I won't go into that in detail, but essentially key people that provide us guidance and advice. And we're based in at the office here in St. George's Terrace, thanks to Eastern Navigation, who are one of our major shareholders. They've provided us an office space in here. So I've attempted on this slide to outline the market opportunity that exists in pipeline removal. Now, so this is all a little bit of crystal ball gazing, and what you're seeing here is, it's looking at Australia, UK, the USA, and the rest of the world, a little bit like World Series cricket. But lots of pipelines. But then the question is, how many will need removal and when will they need removal? This is my best guess at the crystal ball gazing. But before 2030, the key thing is that Australia has got a lot of pipelines to remove. And so it kind of looks like that kind of size of marketplace. And then moving into 2040, there's a lot more pipelines to remove. And what this slide is trying to say here is that the XLA, we're focusing on a beachhead of this $35 billion obtainable market. And this is what SOM is all about, obtainable marketplace. And in that beachhead, we're looking at the first, we're looking at developing that first. Okay, so this slide here, when you see our video, it explains this much more clearly. But essentially, the key point with the Australian beachhead, if you look at how that can be executed, there's a shallow water vessel here that's shown, hookup barge, the WB 400, which is owned by Eastern Navigation, completed Chevron TBI work. There's a DOF vessel that's shown here that can DPCSV. And then you've got a wind farm vessel that can also complete large 400-foot joints, removal of much longer foot joints. So basically, going through the slide deck, there's no shallow water SLA vessels permanently in the region and hardly any left in the world when you start thinking about the shallow water pipelines. There's an oversupply of wind farm vessels. Traditional removal costs seem to be about this sort of cost. And then XLA saves circa those numbers versus conventional solutions. So by 2030, we could be saving greater than $1.6 billion, so quite a lot. And then you'll notice here, so there's where a business model is focused on a royalty, and there'll be some kind of dollars per kilometre that is paid as a royalty for this once we develop it, once we commercialise. So the next slide here, competition. So bear with me here, but this is how we see the competitive marketplace right now. We're uniquely positioned on that left-hand side, and let me explain why we're uniquely positioned. And it's essentially, so the way I see the world is subsea vessel contractors and pipeline vessel contractors, 99% of their focus is on vessel utilisation. Engineering consultants in that bucket in the middle there, with all due respect, engineering consultants are focused 99% on people utilisation. Neither of these, and pipeline vessel contractors are focused on pipeline utilisation. Neither of these generate many new insights or IP. And our focus now, by patenting, qualifying, all the rest of it, is to work together with the subsea vessel contractors to achieve those sorts of costs, reducing costs by 2 relative to your traditional pipeline removal solutions. And then we look on the right-hand side over there at the subsea cut and lift. We believe that around about at the 50-kilometre point, that's the commercial break-even point where subsea cut and lift is no longer commercially viable relative to XLA. And there's a whole argument to be said that it's environmentally worse even at 0 kilometres. So anyway, I'll just leave that up on the page. Then the other point to note is that the thing we don't do, you'll notice on the left-hand side, we don't do all of the typical engineering consulting things. We're just focused in one domain. So when it comes to concept select, screening, etc., it'd be useful if XLA is considered as an early, solution as it rolls out. So here is where we're at with qualification. So what we're doing, we're working with DNV. We're working through 2 stages of qualification. So this first phase here is going to be completed in 2026. This is going to enable us to deploy all of the X-lay on all of the pipelines that are noted on that left-hand side there. You'll see non-concrete weight coated to those sizes and concrete weight coaters to those sizes and water depths. That's focused on the list that we have of Australian pipelines in 2030, the 800 kilometres. So that'll enable us it'll enable the technology to be deployed on those projects to contractors that we're working with. Then phase 2, we're going to focus in on the more complex, and that's basically concrete weight coated, larger diameter, deeper water, et cetera, and we're forecasting, we'll qualify the technology for that, by Q1 2028. And then from a key risks and mitigation perspective, there's lots of these, but I've just summarized the top ones that we see. You see them there, and we believe we've got mitigations in place against all of these. So yeah, that's what we're doing. I won't bother reading from the slide deck. And then I'm sorry if I skip through too quickly. Maybe it's probably about right. So what are we after really? So what we need to enable this is and we have been on this journey for a few years now, and I think a lot of people that are in the audience and other people, over the years, we've been actively seeking partners and stakeholders who are aligned with our vision to enable this solution. So it's basically, in summary, operators facing the pipeline removal iceberg, I call it, because we're just at the tip of an iceberg. And thankfully, we are getting to a point now where we've got tier 1 operators that are seeing this and going, yep, okay, we see the iceberg. There's tier 3 operators that are going, oh, yeah, we see the iceberg. Then we've got DP3, so contractors, subsea contractors, with the suitable vessels. So we can enable, X-lay can enable that the subsea contractors to compete against the pipeline contractors. Shallow water contractors, because there's a unique solution in less than 15 meters of water. And you'll see on our video, as much as that's technically simpler from an X-lay perspective, it's a good proving ground. And there are a bunch of technical challenges with shallow water, as everyone may know. Then the other subsea, so the other area is consultants, engineering consultants. So engineering consultants that we can engage with that are aligned with our vision. Government and regulators. Government is clearly incentivized here because of the tax burden that the public is facing. Plus, there's an opportunity here to develop, scale, and grow a business from Australia that we can take globally and turn this liability of decommissioning into an opportunity. And then finally, strategic investors and government grants, whichever pathway it is that can enable us to get de-risked and to move forward and to commercialize. So that's, I think I've managed to do that in 20 minutes. So that's me. I'll stop sharing.
You did it. Leave your slides on if you would,
okay.
Darren. I've got a question. While the audience has a ponder and maybe puts any questions in, I've got a couple of them.
Okay.
You touched briefly. In fact, you spent a little bit of time on it, but I'd really like to maybe go back to it if we could, in terms of, I guess, for want of a better expression, the operational envelope for where you're looking at for you talked about it in 2 phases. You've got the phase you're seeking to qualify now, and then the second phase. Yes, that down in the bottom right hand corner on the screen.
Yes.
I mean,
yeah.
No, I'm not a pipelines guy. I'm not an offshore water guy, but I'm looking at this and thinking, right, if I had a project and I knew obviously why my pipelines were and so forth, at the most simplistic level, if you were to put a few different envelope pieces around it, high and low water depths, is there Is there a minimum water depth that this would operate in its phase one? Is there a maximum water depth? Alongside of that, pipeline size and pipeline weight. Just sort of where you're going for that first piece. If you could spend maybe a little bit more time and sort of, at least for my little brain, if you could explain that, that'd be brilliant. Thank you.
Absolutely. So I think what I might do is I'll go back to this. Let me go to this image here. So essentially, so starting at the high level view on this. So plastically, as we all know, I should have a prop with me right now, but as you bend steel pipe, we can plastically deform pipe and we can straighten it again.
Yep.
Right. And so, and that's a scalable issue regardless of pipe size and water depth. So the more we can plastically deform, the better we are.
Sorry. I've got a question here. Okay. Just can you please share the screen again? So hopefully it's back for those online. Yeah, thanks, mate.
Yeah,
thank you.
So it's better to think, unlike a pipeline engineer, it is better to think because I often, the things that you can improve on in the world, the subject matter experts will not necessarily improve them. It's actually simply thinking a bit more simplistically. So the simple way to think about this is you can plastically deform. It's a scalable solution. So the more you can plastically deform, the deeper water you can do it in with the particular vessel. The constraints are essentially with a vessel. So with a DP vessel, you've got the constraint of thrust. So you've got a certain amount of tension that you can apply to the pipe. So, some DP vessels are, typically 30 tons maximum forward tension, or 50 tons maybe. So there's a constraint on tension. And tension is a holding that. Pipelay vessels can pull 400, 500 tons at the surface. So they don't have a constraint on tension. So you've got a limitation on tension, and then you've got a stinger radius, and then you've got a water depth, and you've got a pipeline size. So all of those different parameters feed into this thing so that basically, let me go back to here then. So, and Adrian's going to be cringing probably because I'm not explaining it in engineering terms very well, but what you see here, the next thing to look at is the limits, evaluating the limits. So you'll notice maximum ovality, maximum strain, etc. So the DNV code for pipelines currently provides limits on, so ovality, the maximum ovality is 3% and the maximum strain is 0.4%. So what that does is it keeps the pipeline effectively within the elastic zone. And I think a lot of us are all familiar with the elastic curve, where you've got the elastic curve, and then as you bend the pipe, pipe bends and it goes through plastic deformation and eventually it snaps. So what we're doing, what we're evaluating through this DNV stage here and the work that we're doing is all about how far can we, and we're setting some limits right now. We're thinking that a maximum ovality of 7.5%, maximum strain of 1, and then typically pipe tension is lower than 150. That's what we're setting up parameters around. And then what we're doing through phase one. So phase one, you'll notice down in the bottom left-hand corner here. So pipelines less than 20 inch. And the reason we're doing this logically is because Australia is going first in the world. Thailand's already completed the work that they've done. Australia's going first. And when we look at the Australian market, those cases there, less than 20 inch, less than 28 mil of wall thickness, less than 80 meters of water depth. And then we've just picked a particular concrete weight coated size because there's maybe a concrete weight coat pipe that needs to be removed in Australia. And we're going to analyze that in detail. And then that'll give us the detailed parameters.
Yep.
So yep. I hate to take a while to answer the question, but that's really what's going on. And so the DNV process, for people that don't understand it, it's a good time to explain it, is you go through statement of feasibility, then you go, which we've completed. DNV's now told us it's feasible, and here's the red flag, or here's the areas that need to be considered. Then what we're doing is we're working through an endorsement of qualification. So we're going through this threat assessment, FE. I get the acronyms wrong, but we're going through a process of working with DNV to analyze where the threats and issues are. That'll be identified by the end of Q2, and then we go ahead. the statement of qualified technology is we go and complete the things that DNV said we need to do, and they're essentially the gaps. So they've identified the gaps, what are the issues, and then we prove up those gaps from finite element analysis or research of the data, or possibly even pipe testing.
Yep, brilliant. Now, I'll just ask here, as we put a thing in there as well, but someone's put their hand up in the chat. Rather than ask a question on the chat, if you wouldn't mind just typing it into the Q&A on the side, we'll take it on from there. That was good. Thank you for taking the time to explain that. It made a lot of sense, or it started to make sense to me as a non-mechanical person in terms of how you would get to those envelopes. Thanks, Darren. Okay, we've got a couple of questions that have come in. So first one here: what debris can be left behind on the seabed, such as concrete mattresses, protective structures, or does all the debris have to be removed in Australian waters? That's probably not a question for you, but if you want to say anything on that one, then
so the way we're looking at this, there's all associated assets, but we're just even with the pipelines, before the pipeline's removed, regardless of what solution is there, you need to take, you need to remove some of the seabed, and you need to remove some rock bolts, and you need to, disconnect some spool pieces, or take some concrete mattresses out. But that's the same requirement on all particular solutions. So what we do, you park those to one side, and just focusing on the pipeline and the specific pipeline task, what you do see with XLA is, so you imagine when you've got a pipe lay vessel coming in to do removal, then you're not going to use that pipe lay vessel to remove mattresses or clean the seabed, or stable. It's just not cost effective. But because we're using a CSV here, essentially you'll need the same sort of vessel to do the associated activities. So you've already demobbed the vessel with the NextLay system on board, and we're thinking that at the end of the day, those other activities will just be done with the system on standby, and you're doing those as an associated activity.
Cool. Thank you. I missed a question as well. There was a question that had been put in earlier, then I missed it as I'd gone through. You will have covered this very slightly in the answer to my earlier question, but this sort of builds on that one, and that's: to what extent does the pipeline mechanical integrity affect the ability to X-lay pipeline, particularly with regard to corrosion, and how you're going to manage, how would you manage the risks around that?
Yeah. So our approach is basically what we're going to do before the removal is, and you'll notice, so Adrian's Woodside pipeline subject matter expert is also Rosen. So, Rosen has everything to do with the integrity of pipelines. So what we're basically doing well in advance of doing this removal is we're going to assess, for specific pipelines, based on the pigging records and based on the available data, is it possible to do this retrieval with XLay, or are some sections just going to have to be cut out?
Yep.
And that's simply what it is. And then what we're going to do is we're going to model that and analyze it and understand it well in advance of the vessel arriving and having this problem with the bit of pipe pulled over the stern.
Very good. So the next one sort of builds on that one to a certain extent. It says, as you're relying on pipeline strength, does this mean you'll have to do an intelligent pig survey as a mandatory exercise to confirm well thickness? So, I guess just how would you, next, adding on to your earlier answer, maybe, Darren.
Yeah, and so there are, depending on the regulatory environment, there are typically recent, intelligent pipeline surveys. If for the specific case there aren't specific pipeline surveys, then it's going to be a case of risk assessment. Is it achievable or not? But at the end of the day, when I look at this when I look at the solution, the fallback plan for whatever happens is cutting pipe subsea, and retrieving pipe. So it's kind of like whichever scenario you end up in, if you can't pull the pipe on board, if you can't pre-analyze it before, then you're left with cutting subsea. So it's, as with everything, it's never going to solve, it's not aiming to solve 100% of the solutions, even though most engineers try to It's the engineering nature. I'm
Yep.
more of the engineer that goes 80% solved. Let's go and do that.
Yep. Very good.
So,
Okay. Couple more questions here. It's been good. We've had lots of questions coming through. So how would you be able to deploy subsea vessels for steel pipe retrieval, considering the length of recovered pipe X-lay can achieve that you have shown us in the presentation? These subsea vessels all have an LOA much shorter than pipe lay vessels. In other words, what LOA subsea vessels are you considering?
So I'll encourage that person to just look at the 6-minute video. It's pretty self-explanatory, and
Sorry.
and that just go and look at it. It's like you'll see it. It's kind of obvious once you see the video, but that's scalable all the way to 400 foot. And the reason it's scalable to 400 foot is because you can take a wind farm vessel in 2030. And I'm putting a bet in the casino that wind farm vessels aren't going to be going for very much in 2030, because the wind farm vessel market, much like rig market or whatever, could be oversupplied for a limited demand for wind assets. Let's put it that way.
Mm-hmm.
So yeah, so there's a long aircraft carrier deck vessel that can pull very long pieces of pipe. Right. through to the one. I show exactly why you can pull 160-foot joints on the video.
Excellent, thank you. So of course, go watch the video. We will include the link to the video with this when we load it up on YouTube as well. So for anybody that's watching this, that then sort of trying to work out where the heck the video is, we'll include a link to it as well. So next question, and thanks Jamie for putting this one in, because you were, I think, the one that had your hand up to ask. So I really appreciate you typing it in. Okay, how will you manage the risk of buckles and recovering from it if you're deliberately plastic deforming the pipeline? And how are you thinking you will manage localized corrosion? Would you need to have good inspection data? So again, the corrosion inspection question again.
It is, and so the work that we're doing. So we're doing our DNV work. We're also we're looking at we're tier 1 operator and or a local university. There's a research project right now, and so we're looking at this. We're analysing it and we're figuring it out, and we're going to be working in finer detail. Is all I can really say.
Fair enough.
In order to move forward. It's a little bit like watching. I'm the type of person that's watching the NASA lunar, the lunar, and they're going around the moon right now. And I'm going, yeah, wasn't that 1963? But there's, in order to push boundaries and limits, you need to, I don't know, we need to do R&D and try and test new limits. Specifically, the way I see the world right now, with decommissioning, as you know, Francis. Decommissioning's there's a new norm in place where we have to find more efficient solutions, because at the end of the decommissioning cycle, the operators are left with zero revenue. It's not like they get to the end of a development cycle and there's some oil or gas revenue coming into the tank to forgive all sins.
Mm-hmm.
So we need to get smarter and better, and the only way to do that is have these sorts of conversations, I think.
For sure. Yeah. So last of the questions at the moment that are in the chat for you, and that's how can you rely on your tensioner without having certainties on friction values with the pipe, for instance, concrete weight coating deterioration or coating status?
Well, again, what that's going to be is inspection, analysis. We put it this way: we're going to start phase 1 where there's no concrete weight coating. And that'll save $1 billion.
Yeah.
And then then we're looking at the next phase. The next phase is concrete weight coating and what's involved, and that takes a bit more R&D and research. But it's a question of how the best way to look at this is how big is the prize? Is it worth chasing? Is it worth figuring that out? If what's achievable, rather than going, this is not possible. Yeah. I'm not from the world of not possible.
Yeah. What I'm hearing is very similar to what I hear when I talk to the people developing well tooling, that right. They'll build a tool for a particular well, for a particular characteristic, diameter of well, number of strings and so forth. And then as the market will come along and say, oh, can you make one for this size? Can you make one for that size? I'm hearing similar from you around this, that you'll start off with, here's where we think the big the big need is right now, or the big opportunity, or the best fit is.
Exactly.
And then you'll build on that into broader market offering and more information as you get the experience as you go. Yeah.
Yep.
Excellent. So,
Cool.
second question from me, and while you're answering mine, I'll have another look and see if there's any more come in. So, what's your anticipated timeline before someone can actually start using this? You know, you've talked through sort of where you are, where you're going with DNV. There's some timelines nominally shown on this slide, for instance. But for someone to be able to say with confidence, right, I'm going to start booking a boat. What tooling do I need? What do I need to manufacture? How do I get all this lot together? What would you say for someone that's got that Goldilocks pipeline, if you like, that fits just in your envelope of design that you've got here? What would your time to market be?
Well, there's the DNV. There's sort of two questions to answer. DNV qualification kind of independently says this technology is qualified and ready to use. Then there's the next question of the specific operator. Is there any other requirements or any other needs that that specific operator may have? What we're aiming to do is we're looking at a specific market right now. You know, we're looking at the specific market, and we're working with those specific operators and asking them now and involving them in the process so that we can shorten the time from, let's say, the end of DNV qualification until the first operator has the need. Then we're looking at pipelines in, for instance, in shallow individual pipelines. Maybe it's not the full 800 kilometers of pipelines, but we're looking at individual pipelines in shallow water for the first pilot or first project. But in answer to your question, it's the timeline from basically award to being able to execute offshore is 18 months to 2 years. Really, that cycle of, yes, here's a FID, here's a, before all of that, we're bidding on a project, obviously, but FID through to delivery is something in that 18 months to 2 year horizon.
Very good. And while you were answering that, we've had one more question come in, which is a question following on to a question that you've already answered. But anyway, so this is the question here. Will your system be able to recover concrete coated pipe using small and cheap subsea construction vessels?
Hopefully, yes.
Yep. Yeah, hopefully, yes. I love that. Yeah. Again, as you say, the optimist in you, mate.
Yeah.
Yeah.
Got to start somewhere.
Indeed. Yes. No, look, that's been great. I'll just have a really quick check, make sure there are no more questions here. No, we're all good. We've addressed everything. So, look, Darren, thank you very much for your time on this.
No, thanks a lot, Francis.
Exciting and interesting to see a new idea being brought along and nurtured, and hopefully coming to market to suit those applications in the not too distant future. Everybody on the call, thank you very much for your questions, for joining us, and for staying on the journey here with Darren in terms of going through where he's at. If you want to share this with your friends and colleagues, this will be edited, copied, and loaded up to our YouTube channel in the next few days. So watch out for it in there if you want to catch up on any little bits that you may have missed along the journey. And Darren, your contact details were all over the first page, and I think the last page on this as well. So anybody that wants to grab a hold of you for a follow-up chat, that they've got a couple of $100,000 burning a hole in their bank account, they're ready to tip in to help get this technology along the road even quicker. They know where to get a hold of you. And look, on that, thank you everyone for your time. Really appreciate it. And watch this channel. We have another webinar next week. Totally different bit of technology. You'll be pleased to know you have a much better host than me as well running it. So yeah, feel free, watch out for that one, because I think it's around about this time next week that one's on as well. And yeah, thank you everybody. Thank you.
If I could just say, Francis, thanks a lot for being there at the different parts of the journey. So it's great that CODA exists for this forum to enable all different types of new ideas to cross-pollinate all around the world. So thanks very much.
Thank you very much. And that's a totally unrequested plug, but
Yeah.
we'll take it anyway. Awesome. Thank you, Darren. And thanks, everybody. And see you on the next one. Cheers now.